All right, so we've got 1:03 Eastern Time. We're going to go ahead and get started. Thanks, everyone, for joining us. My name is Rick, and I'm with the Project Spectrum team. We're certainly happy to have you with us here today for this Cyber Circuits. Today, we're going to be talking to, again, a great guest about the manufacturing industry and cybersecurity. So we're going to get into that. But before I do that, I would like to introduce Mr. Kareem Sykes. He is with Project Spectrum's Industry and Engagement team. And so, Kareem, why don't you go ahead and say hello and let everybody know all the great stuff there is to know about Project Spectrum.
Excellent. Thank you very much, Rick, and happy to be here again. Want to welcome everyone and really thank everyone who is here. We know that you've taken time out of your day to join us here for this edition of our Cyber Circuit event. As you recall, this is an event that we'd like to do to bring in industry professionals and subject matter experts across the federal government, private industry, as well as the defense industrial base and beyond. And so we're here today talking about cybersecurity in the manufacturing critical infrastructure sector. Could not be more germane and apropos to bring in the wonderful guest that I'll leave you. I'll let Rick introduce for us, but we're happy to have Dr. Banerjee with us. He's an absolute professional, and his experience is unparalleled in many respects. And so we want to, again, welcome you all today. As you know, manufacturing is the cornerstone of our economy, and it faces an increasing array of cyber threats that can disrupt operations, compromise data integrity, and even potentially put lives at risk. And so when we think about small businesses within this sector, they often find themselves at a unique intersection, right? Where essentially limited resources meet high cybersecurity risks. And it's essential for us to understand that, while the threats may be daunting, that there are actionable steps that every business, and particularly small manufacturers, can take to bolster their cybersecurity posture. And so we invite everyone that's with us today, if you've not already registered at projectspectrum.io, we would certainly love to have you do that. Again, today we're joined by Dr. Nilanjan Banerjee, a leading expert in the field of cybersecurity, extensive experience working with both large enterprises and small businesses and academia, again, to address and really research and tell us about some expertise that he's been able to garner and glean working with many of the challenges facing cybersecurity. So again, we look forward to that discussion. And again, I encourage you to think about critical systems that you have in place and how vulnerable that those might be. And again, what proactive steps you can take to help protect your small business. Again, cybersecurity is not just an IT issue. Obviously, there's operational technology concerns, certainly germane to the manufacturing sector, which I'm sure we'll hear more about today. Without further ado, I'm going to pass it back to you, Rick. Thank you very much. And again, welcome. We thank you all for taking time.
Thanks so much, Kareem. We appreciate that information. And yes, we are going to get to our guest. I'm going to introduce him in just a moment. Before I do that, I did want to just give a couple of housekeeping items. So everybody who has joined us today, your cameras are off and your microphones are on mute. What we would ask is that if you have questions anytime during this webinar, please go ahead and use the Q&A feature at the top of the Teams window and type your question into there. The Project Spectrum team is standing by. They're going to be compiling the questions, and then we'll be putting those forward throughout the session, whether it's during the session or afterwards. So we are going to leave some time at the end for some Q&A. So without any further ado, I do want to introduce our guest today. It is Dr. Nilanjan Banerjee. Nilanjan is a professor of computer science and electrical engineering at the University of Maryland, Baltimore County, which is UMBC. He is also the Associate Director of Cybersecurity in Manufacturing at UMBC. And we want to make sure that we're noting that he is a director for the Center for Research in Emerging Manufacturing. That's also known as CREM. And that is a collaboration with the U.S. Army that is a leader in digital manufacturing, Industry 4.0 research and training, cybersecurity research and training, compliant cloud computing systems, creating cloud computing systems, and creating digital enterprises for global supply chain. So without further ado, welcome I want to call you Dr. Banerjee, but I also want to call you Nilanjan because I know you very well. So I'm just going to call you Nilanjan if that's okay.
That's perfectly fine, Rick. Thank you so much for the introduction.
Oh, my pleasure. It is a great pleasure to have you on here because, again, as Kareem had mentioned, you are really a very notable expert in this area. And I know that a lot of our attendees today and a lot of the folks that are going to be tuning in to the replay later on are going to be very interested in what you have to talk about because, again, this is manufacturing is definitely one of the areas where there's a lot of concern when it comes to cybersecurity, because as we like to tell people, cybersecurity is not a destination, it's a journey, and it's continually ongoing. And as manufacturing continues to grow and evolve, the processes, the systems, the tools, as they continue to grow and evolve, that's when those extra threats really come in. So we're really glad that you took the time today to talk to us about that. So I want to start out with a pretty easy question that we're hoping to get the layman's terms on this. But when you're talking about operational technology, just what exactly is that, and how does it relate to the manufacturing industry?
That's a great question to start with. So operational technology refers to the hardware and software systems that monitor physical devices, processes, or infrastructure, usually in industrial environments. So common sectors is manufacturing, also energy, utility, transportation, pipelines. All of these systems essentially are driven nowadays with industrial control systems, which are part of operational technology. So operational technology, or OT, would include tools such as programmable logic controllers, PLCs, SCADA systems, distributed control systems. All of these are kind of tailored towards specific industrial task. How is it different from, say, information technology systems? Well, information technology systems like your computers that you use for your HR tasks, or basically, say, building code for web applications and things of that nature, those systems usually manage data, okay? And operational technology systems interact directly with the physical world, right? Such as, say, motors, or controlling temperatures, regulating pressures, etc. And how is OT related to manufacturing? Well, OT systems are used in manufacturing for various purposes. For example, if you have a conveyor belt is usually driven by programmable logic controllers and SCADA systems that potentially make sure that the industrial control system work. It's used for automation and efficiency, process monitoring and control, safety and reliability. Also, you potentially integrate nowadays with IT systems to ensure that you have remote control and such. So in a nutshell, operational technology is basically the backbone of modern manufacturing. And it provides the tools and systems that are needed to automate, control, and optimize these production processes.
No, and it's incredible because we really don't necessarily think about that as being part of the manufacturing process. But like you said, it's the backbone. It is controlling the nerve center really, and holding all of those cards. So I have to imagine that there are a number of cybersecurity threats that are faced by manufacturing setups and shop floors when it comes to their operational technology systems, right?
Absolutely, yes. And almost anything that can happen from a cybersecurity perspective in an IT system can happen in an OT system as well. So there is a plethora of ransomware attacks, for instance, that happen in OT systems. So attackers target OT environments, basically encrypt critical systems or data, and then demand like ransom for their release. And there are multiple examples of that. Phishing and social engineering attacks, like if people are able, or bad actors are able to get access to, say, your manufacturing shop floor, your IP, as well as your production environment itself could be stalled for a very long time. And remember that OT systems are built with the notion of like continuous availability. So say you have a pipeline and an OT system is driving the pipeline, and suddenly somebody attacks the pipeline, has a ransomware attack, and essentially the basic premise of why you have an OT system for 100% availability is lost. So the economic aftermaths of these attacks could be huge, and this is just a few examples, right? So you could have insider threats, you could have malware, advanced persistent threats that could potentially attack these OT systems, unauthorized remote access, which is also true for IT systems, legacy system vulnerabilities. So a lot of I would say OT networks and systems actually use old hardware, right? Hardware which potentially does not provide you with the is not patched for vulnerabilities, and such legacy systems could potentially also be attacked at their interfaces or on the system itself to garner like critical like IP information. You could also launch many stock attacks like denial of service attacks on OT system and stop production for a long time. So almost every attack or cyber attack rather, that you can think of in an information technology system can be launched on an OT system as well.
And you know, we've often said that when it comes to manufacturing, particularly when you're talking about small and medium-sized businesses, their resources are really aimed at meeting their production deadlines and hitting their revenue targets. And so a lot of times you have something like cybersecurity that is it's important. Obviously, I don't know anybody that's ever going to say cybersecurity isn't important, but we've heard the excuse not in the budget for this year, or you know we're doing everything we can. We make sure we tell people don't open bad emails, but it really, like you said, it really goes much deeper than that, especially when you're talking about those legacy systems, because again. We've had discussions on the Project Spectrum side with manufacturers who they have to use legacy systems. They have to use an older version of Windows because the software that controls their machinery won't work on Windows 11. And so it's one of those instances where they're not necessarily using them because they just don't care or they prefer it. They're using it because it's almost a necessity. And so then it becomes, how exactly do you help control that? I mean, is it really just the legacy systems when it comes to small and medium-sized manufacturers that are the big reason of the increase in cyber threats, or is it are there other factors that are at play for all of these bad actors to continue to go after the small and medium-sized businesses?
So legacy systems are probably not the only reason why there are vulnerabilities that are exposed by these OT systems. One of the big industrial revolution right now is Industry 4.0, and now people are talking about Industry 5.0. What that means is everybody wants to be connected and interconnected, even in the manufacturing and OT sector. So what does that mean? You want to sit in your house and you want to potentially control your shop floor, right? And that sort of connectivity gives you a lot of flexibility in terms of doing your work. However, what that means is that also opens up the attack surface. So if somebody is able to say, get access to your OT system through your IT network, that could be highly detrimental to you. There are solutions around it, and some of these are just best practice cyber hygiene solutions. One example is network segmentation, right? So it is extremely bad practice to have a flat network topology between your IT system and your OT system. There should be network segmentation where your IT network is potentially segmented out from your OT network. Or there is a very powerful firewall that sits in between that ensures that access to your OT network or your manufacturing shop floor is properly access controlled, right? So while legacy systems do expose a lot of vulnerabilities, I think it's the interconnectedness and the connectivity that people want for their ease of use that exposes a lot of these operational technology systems to cyber attacks. One example I would give you is the smart grid, right? So in the past, grid used to be somewhat air-gapped, right? Just having a system air-gapped, though, does not necessarily mean that it's completely secure, but air-gapping potentially ensures that the attack surface at least is minimized, right? But today, smart meters, you essentially want to access from your house. You want to remotely log into those terminals and be able to access all the SCADA data and be able to do process automation from a remote terminal. So that sort of interconnectedness can potentially open up a lot of, I would say, the attack surface that attackers could potentially leverage.
Right. And so, you talked about that, wanting the remote access and wanting that ease of access, right? And we know that anything that is connected externally is going to be a problem, is going to be a vulnerability. And are there things that these small and medium-sized companies can do, or are there steps that they could take in order to reduce that risk a little bit more, or to protect themselves better against these potential attacks? Because again, when it comes to small and medium-sized businesses, they're easier targets for bad actors, and so they're constantly going to be under attack. And you obviously want to try to walk that tightrope between whether or not you can have that ease of access to your machinery, to your software, to your meters, to whatever you need to do business, versus having that larger vulnerability to a potential cyber attack.
Yeah, so I would also point out that a lot of existing cyber attacks that have happened in the past has happened because of human error, right? So, for example, like somebody downloading a malware from their email, or like plugging in, say, a USB stick into even an air-gapped network. The Stuxnet attack was an example in 2010. This was basically an attack where you had a nuclear power plant in Iran, and it was in an air-gapped network. So you could not necessarily access that nuclear power plant from outside. But the intuition is somebody plugged in a USB stick onto a terminal, and this very sophisticated malware, which was also a rootkit, essentially used some of the zero-day vulnerabilities on the Windows operating system to get access, I think, to the centrifuges. And it was such a smart attack where they would just control the speed of the centrifuges, like high or low, which made the centrifuges fail over a period of time, right? So this could have been easily prevented if there was a policy in place in an environment like a nuclear power plant that nobody should bring in any external USB stick and plug it into their Windows machine. It was an air-gapped network, right? Similarly, the ransomware attacks that have happened in the past, for example, the Honda cyber attack, you might have heard about it in 2020. That attack was essentially a ransomware where the Honda's global production was disrupted that due to the specific ransomware, which was targeting their industrial control system. But how did that attack make it, or the ransomware make it into the network? Probably due to a human error, right? So you downloaded something, might seem like an email from your CEO with an attachment on there. You did not check or verify that was an actual email from your CEO, and you downloaded that malware onto your machine. And since you were in the IT network, and the IT network was not properly segmented from your OT network, that malware percolates now to something way more important than your IT network, which is your operational technology network, your production network, your industrial control systems. So a lot of this, I think we can talk about like complicated solutions to ensure that these human errors could be minimized, but you can go a long way just through proper like cyber hygiene and training, in my opinion, right? I'm an academic, so I would always talk about like somewhat complicated research problems. But talking to small and medium manufacturers through my center, what I found is about 80 or 85% of these issues could be fixed if the individuals who are working in these systems were properly trained on what they should or should not be doing with respect to certain things, like very simple things like attachment downloads, for instance, right? Or say, as I said, plugging in a USB stick onto a Windows terminal within a nuclear power plant. That should be a big no-no, right? So yeah, so a lot of these could be fixed to simple training and simple cyber hygiene. But there are nowadays like fairly sophisticated techniques that you could deploy, say, on your firewall in between your OT and IT network, which would be continuously doing intrusion detection to ensure that there is nothing going on or going in from your IT network into your OT system that you don't know. There is work going on behavioral analysis, right? So basically implementing zero trust within an OT network. So, okay, an attacker is in your network. How do I determine that the attacker is in my network, and how can I isolate them, right? So people have been using data-driven approaches, mostly machine learning techniques, to see what is normal versus what is abnormal, and then very quickly like shut down certain parts of, say, an industrial control system if they think there is an attack. Another challenge here is it's very difficult in many cases for these algorithms to determine an error versus a cyber attack. But my reasoning here is, even if I have false positives, right? So it is an error that has happened in your system, and I think it's a cyber attack. I would still try to take remedial action, because if it was a cyber attack, the aftermaths would be detrimental. So,
right, because you would have to think that there's no such thing as being too safe or being too paranoid in these situations, because just like you said, we always refer to it as what problem exists between keyboard and chair, and human error is human error because it's human nature and we're imperfect beings. But at the same time, I mean, you do something very innocuous. You get an email, like you said, that looks like it's from the CEO that says this document needs to be downloaded and printed immediately. And you think you're being a good corporate citizen, and you click that, you download the attachment, you open it, and then boom. Or, you talked about, before about the USB drives. I mean, how many times have you found a USB drive laying around and you're thinking, I don't even remember what's on this thing. Let me just go ahead and plug it into my computer. And you don't even know that it's yours. And there have been documented cases where bad actors have left the USB drive laying outside of a doorway in a secure building, figuring somebody's going to pick it up, think somebody lost it. They're going to take it in. They're going to plug it into their computer in the office, and they're going to see what's on that drive. And the next thing you know, like you said, it ends up causing a huge problem. So, I would have to think that sometimes it's better to take that. It's better to be safer than suffering posture when it comes to something like this. And you talked about the more sophisticated measures, and we've heard from manufacturers that when it really comes to network segmentation, that doing it properly is a challenge. So I mean, are there recommended techniques, or are there best practices for implementing some sort of network segmentation on a manufacturing shop floor, so that you, again, are keeping those systems separate?
Yeah, so it depends on the size of your industrial control system, right? So the first step is to ensure that your information technology network is segmented out from your OT network. It's very bad practice to have any element of your OT system directly accessible from outside, from the internet, basically, right? So that's one level of network segmentation that you can do, is ensure that your IT network and your OT network is segmented and essentially has a very powerful firewall in between. So there are companies that would potentially sell you routers, for lack of a better word, which have very powerful firewalls and intrusion detection systems that would run on these routers, which sit in the middle of your IT and OT system. So that's one level. But again, it depends on like how big your OT network is. So if it's a smart grid, if it's a big company like Constellation, for instance, they would potentially have different components of the OT network itself that needs to be segmented from each other. So the network topology design, like of which part of your network you should completely segment from the other, in some sense depends on what you're doing in that OT network. If there is something sensitive going on, as part of your manufacturing process, say you have a core piece of IP that you're implementing in a specific part of your manufacturing shop, it makes sense that the equipment that sits in that part of the network is somewhat isolated from everything else, right? But for small shop floors, for instance, the ones that I usually work with around the university, they have, say they are an additive manufacturing shop, they would have a bunch of these 3D printers all tied together in one network. And their IT network in many cases would be directly tied to that OT network, right? So without any firewall in between. So say, and again, bringing back the malware example, somebody is an HR person, he or she is not a cybersecurity expert, suddenly downloads a piece of malware onto their desktop and it's totally connected to your additive manufacturing setup. It's quite easy for that to be percolated over to the OT system. So again, network segmentation itself, how you would segment it and where you would segment the network is usually a function of like what you are doing on your OT side. But as a very coarse-grained solution, at least the OT systems and the IT systems should be segmented with a firewall. And any cybersecurity expert would say you tell that to you, any company that you go to. That's the bare minimum that you should be doing. Yeah.
Right. And then I also have to wonder how convergence is going to play into all this, because I mean, we see it all of the times. We're simply trying to make things more efficient and better and easier. And so you're bringing these systems that normally wouldn't be together on a device or together on a network, you're bringing them all together into one network because, again, you want to have that efficiency, you want to have that ease of operations. So as OT and IT have continued this convergence, I have to think that it's going to really increase that whole threat surface for manufacturing. So is there a way that, you know, particularly when you're looking at the smaller and medium-sized companies, because you mentioned something before, if you're a Constellation Energy, you know, we hear that all of the time when we work with companies that are in the mentor protege program, where the larger company says to the smaller company, oh, all you have to do is just, you know, let your 7 IT people deal with it. And the smaller company says, no, my IT person is someone who wears actually 7 different hats. So there's always that miscommunication between larger and smaller companies. So when it comes to smaller and medium companies, what exactly can they do to address the challenges of OT and IT convergence?
Yeah, I would go back to network segmentation on the shop floor. There are multiple ways of actually doing network segmentation, and I didn't go into that detail. Zoning is one example, right? I talked about deploying firewalls between the IT and OT networks. You could also use virtual local area networks to ensure that you have that segmentation. These are simple techniques, but these have to be set up properly for your specific case. You can go a level deeper and use like IDMZs, which are industrial demilitarized zones, right? So just network zones that needs to bridge between IT and OT. You could use simple like operating systems techniques like access control lists to ensure that the access to your OT network or say your SCADA system is only given to individuals who are working on the shop floor. So access control techniques like that could be used for network segmentation. You could also use techniques like micro segmentation, which are highly granular. Like, again, if you have a very large OT system, OT network, you have power plants all over the place, you have a grid in between, then you could potentially implement micro segmentation, which makes every part of your OT system somewhat segmented from each other with proper firewalls in between. So several techniques exist, and there are like industrial quality tools that a lot of these bigger companies are building that you could just use. They're not cheap to use, but if you are looking for a very simple solution, what I would recommend is, again, if you're a single shop floor, and you have some part of your IT system, implement some simple network segmentation with, say, a firewall in between your OT and IT system, and you control access of an individual who is gonna have access to your shop floor. Don't give privileges to everybody, right? Only the engineers or individuals who are working, or process control analysts who are working on the ICS system should have access to that part of the network. So yeah, simple access control techniques could also help in this regard.
And then obviously in your position as an academic, this is something that you have, I'm sure, focused a lot of time and effort to do research in this area. Can you clue us into some of the research that you've been doing when it comes to operational technology?
Yeah, so my lab or my center right now is focusing on like 3 core areas in operational technology, cybersecurity. One is implementing zero trust into these operational technology systems. So in the past, operational technology systems have been secure through obfuscation. What that means is a lot of things that potentially run on these OT systems, right? Say a Siemens PLC, the software is not open source, right? So people don't necessarily have a very good idea of, or bad actors would have a very good idea of like how to hack into that system, right? But with this IT-OT convergence that we were talking about, some of this is going away. So what we have been trying to implement, and this is still very researchy, is we have been trying to build trusted execution environments into these OT systems like PLCs. So what does that mean? So a trusted execution environment is like a secure enclave, right? And an enclave that is potentially built in small embedded systems like microcontrollers and such. So what we have been trying to do is using ARM Trust Zone, essentially build these trusted execution environments that can be plug and play into PLCs, inverter-based resources, and other ICS systems. So what that provides you with is trust in the system itself. Like, how do you ensure that that particular system has not been attacked, right? Through concepts like secure boot, remote attestation, and any computation that happens within that trusted execution environment, I can ensure that that entire inverter-based resource itself is trusted, right? And if something bad happens, the next part of my research looks at how can I make these operational technology systems potentially work in degraded modes in the presence of an attack. So one of the things I started with when I was defining operational technology systems is one of the requirements is availability, right? So you don't want the pipeline to stop, right? You don't want the smart grid to stop. You want almost 100% availability. You don't want a shop floor and production to stop in any case, even if there is a cyber attack, right? So how do I have like redundancy built into these industrial control systems such that if there is an attack, can I make the system at least operational in a degraded mode? So one of the problems with, of course, OT systems, they're very diverse, right? And in many cases, they are not very standardized. We are moving towards that direction, but they're not standardized. So some of these techniques have to be built on a machine by machine basis. So if you have a subtractive or a CNC shop, or if you have, say, an additive manufacturing shop, or you have an assembly station, right? The way you would potentially build all of these TEs and these isolation methods would be specific to that particular infrastructure. So big thing is one of the big things is building these TEs so that I can induce trust into all of the components in the OT network. The second part of my research is looking at, like, if there is a cyber attack, how can I have these redundant states in the industrial control system so that the industrial control system is still operational, but maybe at a degraded mode. And the third thing that we have been looking at quite a lot is, in many cases, since these are slightly closed systems, it's very difficult to muck with the software in such a way that you can monitor attacks, right? So we have been using a slightly higher level behavioral analysis where, say, we are looking at a PLC on a conveyor belt. Is the behavior of that PLC normal, or the behavior of that PLC is abnormal? So if it's abnormal, probably it's an error or a cyber attack, right? And as I said earlier, like, even if I have false positives in this particular case, I'm okay with that. Like, I can tag them, take a look at if there is a cyber attack, and then close down the system as required. So the third part of my research is looking at these data-driven models where I try to build digital replicas or digital twins of these industrial control systems and look at normal versus abnormal behavior. And if it's an abnormal behavior, I tag it as a possible cyber attack, which needs to look, which requires the analyst to look further into it. Yeah.
No, and that is absolutely fascinating, particularly like you said, when you're talking about, can the system still operate in a degraded fashion? Because in particularly in manufacturing, I mean, anybody will tell you that, some output is better than zero output. And so it's really about making sure that you're getting the really critical functions back online as quickly as possible, and then whatever isn't as critical you can take your time with. Now, we talked before, you've mentioned your research. We talked before about the human error. So I have to say, or I have to surmise, that you tend to see a lot of opportunities for training and workforce development in this particular space. What are some of the areas that you think should be a main focus for small and medium-sized manufacturers?
Yeah, so I wanted to point out, as a shameless plug, so at the university, we are building, I would say, one of the very few open operational technology cyber ranges. So this is basically a factory floor that we are building with a conveyor belt, with a miniaturized smart grid, also subtractive manufacturing processes, CNC machines, basically, as well as additive manufacturing machines. But the goal of this particular piece of infrastructure is to be able to do cyber exercises on it. We use like stock Allen Bradley and Siemens PLCs, for example, for our conveyor belts. So this is one resource that we have been using for hands-on training of small and medium manufacturers right now around them in the Maryland area, near Baltimore, to essentially come in and get like hands-on training on both Industry 4.0, like the connectivity, digital manufacturing aspect of it, and also like launch, like do things like red team, blue team exercises to understand like how to attack the system and also how to defend the system, right? There is another program that we have been doing right now with MXD, the Digital Manufacturing Institute. The program is called CyMOT. The CyMOT is completely free. It's basically cybersecurity curriculum for operational technology, where we have been offering role-based curriculum using our cyber range, where these are short courses that we offer in, say, advanced penetration testing, manufacturing penetration testing, even cybersecurity fundamentals, where an individual who is in a small business can now get upskilled in a specific role around, say, cybersecurity analyst. So again, 20-hour courses, totally, so synchronous courses right now with an instructor in the loop, and it's offered completely free. So in the past, I think 1 year, we have had about 250 manufacturers go through this specific training. This training is now freely available through the virtual training center at MXD. So So the training that we can offer, in many cases, I think which has worked out based on my experiences, is hands-on training, right? Of course, you need some lecture material on trying to understand the fundamentals of cybersecurity, the fundamentals of industrial control systems, the protocols that are used. But what we have found is access to this particular piece of infrastructure, the cyber range, helps manufacturers really try out different things. One of the caveats, obviously, with this specific type of training that I'm mentioning is we have certain types of equipment in the cyber range, right? We don't have every type of equipment that you might be using, like in your small business, but the protocols, right, are usually similar, right, across different types of equipment. So that knowledge could potentially be translated. So for instance, we have had people in the biopharma manufacturing industry. We have had folks in the defense manufacturing industry come in and take training from this specific platform. I'm also aware that your team, Rick, at Project Spectrum, is planning to offer a similar type of training in collaboration with the university, which provides role-based training, but hands-on training using this specific cyber range.
Yeah, I was going to say before, when you mentioned a shameless plug, we certainly don't mind those. We will do that ourselves, because again, when you're talking about those resources to the workforce and development, and let me just say kudos to the University of Maryland for working to make these resources free and easily accessible. So, a big shout out to your folks there for that. But, when it comes to the tools, training, and resources Project Spectrum offers, this is, again, one of those instances where we're trying to make sure that any size business, any industry, they can come into Project Spectrum at no cost. They can access our training courses. They can access our tools. They can access news and other resources. We have the self-assessments where we're constantly trying to help companies build that cybersecurity posture, because they again, you sometimes just don't realize it. I always like to go back to some of the control families when it comes to NIST 800-171 or CMMC, where you think about access control and you don't think about your loading dock and how many people have access to that. And so even then, think about the shop floor. Think about how many people could potentially have access to a shop floor. If something were to if a piece of equipment were to go down and you're letting folks in there just to repair it, who aren't on staff, because again, small and medium-sized manufacturers don't really have that luxury to have somebody on staff who can repair these things. You often have to bring people in from the outside. You're giving unfettered access to your shop floor to somebody who's going to be poking around and doing things to try to get things up and running, but even potentially could cause some harm. So again, thank you so much. We love that you offer that. We're coming up on 46 past the hour, so want to make sure that we're giving time for some Q&A. We do have a few questions that we've gotten to, but before I do that, is there anything else that you want to say before we head into Q&A about the resources and advisory services that are available to manufacturers through all of the efforts that you're doing?
Yeah, so I work very closely with the MEPs as well, especially the Maryland MEP. I found them to be quite very useful resource to help with training, and not necessarily just cybersecurity and manufacturing, but also digital manufacturing, upgrading your shop floors and things. So MEPs are great. Of course, there are Apex accelerators that I've not worked with closely myself, but I've heard of. They're not specific to manufacturing, but in general, small businesses. I've heard from some of my friends who run small businesses that their advisory services have been quite helpful as well. And the manufacturing innovation institutes, their business models are a little different than, say, an MEP or say Apex accelerators. They usually cater to to their members. But there is an entire manufacturing institute out of San Antonio that's just focused on cybersecurity and manufacturing. They provide a lot of free resources as well to non-members. We are not a member, for instance, the university is not, but I listen to those resources. They have been doing work just focused on cybersecurity and manufacturing. So MIIs would be another set of resources that I think may be worth looking at. Yeah.
Excellent, excellent. Well, I want to get to a couple of questions. First one is coming from Kimberly Jones. Kimberly, thank you so much for chiming in. She mentions that oftentimes you get companies like Xfinity that are stating, that they're going to provide security, for your network or whatever through, the ISP. But do you find it a recommended practice that companies get their own security system or at least a VPN to help protect themselves?
I completely agree with that. I don't know about Xfinity, that specific company itself, but one of the things that bothers me about Xfinity is they have access points all over the place and my phone always connects to it. But apart from that, having some of these companies potentially come in and set up cybersecurity controls in your infrastructure makes a lot of sense. If you have that in-house, that's the best, right? But if you need outside help to potentially set up your networks in such a way, network segmentation, for instance, it's not a trivial piece of work, right? To just segment your different parts of your IT network or your IT network and OT network. You can get these companies to come in and set those up for you. Of course, the bigger question is what the costs are and things of that nature, but I would recommend them, yeah. Not Xfinity in general, and these companies in general. So
yes, nope, we understand that, and I know exactly what we're talking about those access points, because it really does. It connects you right to them, and there again, we do these things in the name of convenience, because sometimes the cell signal is not quite what you would want it to be in a particular area, but the next thing you know, you jump onto this access point and it could suddenly become the Wild West very quickly. So we have another question from Kurt Warden. If we presume that the objective of OT and IT convergence is to enhance efficiency, particularly when it comes to time and financial resources, and that the means to achieve this efficiency are to allocate resources, both financial and human capital, then an evaluation of the value generated must be conducted prior to implementation. So how would you recommend that value analysis be conducted?
That's a great question. So one of the advantages, one of the direct advantages of OT-IT convergence and remote access is also financial cost saving, right? So if there are certain things that you can automate and you can do remotely, the human capital that you have to invest to potentially carry out those tasks are minimal, right? But given that the cybersecurity controls that you have to put in place has its own cost, okay? So doing a cost analysis is a very good idea. So what you need to look at is how much cost savings does this, as a simple example, remote access providing you with, right? And if you want to implement, say, a virtual private network, just as an example, or you want to implement some of this network segmentation approaches from a cybersecurity perspective, how much cost does that lead to? And then you can do a side-by-side comparison. One of the things, however, I must point out is the financial benefits of implementing these cybersecurity controls is not immediately visible, right? So as the saying goes in my community, it's not necessarily whether you'll be attacked, it's when you would be attacked, right? And so you need to potentially factor in that cost, right? Say somebody gets access to your shop floor, right? And the type of attacks, ransomware attacks, for instance, that you listen to or you find in the headlines is a very small subset of the attacks that happens. Like a couple of months ago, the smaller business in Baltimore had a ransomware attack, never made it to the headlines, but their operation was stopped for like like a month, and they had to pay about like $1 million to ensure that whatever files were encrypted by this ransomware essentially were decrypted and given back to them. So that cost also needs to be, that long-term cost, if you were attacked, needs to be factored in to see if you want to invest in cybersecurity right now or not. Understand it's a trade-off as usual, but the efficiency costs plus like what additional efficiency savings, I would say, plus the cost that you have to incur to put in the cybersecurity controls, you have to look at it side by side and see whether it's beneficial for you or not.
Right, and that's one of the things that Project Spectrum has always been preaching is the cost of a cyber attack it's not just a one-time thing, particularly when it comes to ransomware. You could pay the ransom and you could get your files back, but then now things have evolved a little bit more. Now you have extortionware, where it's okay, so we've given you your files back, but how much more are you going to pay us to not release your IP out into the world and to put this information out to everybody? So you have something like that. So it's constantly and then the cost of reputational damage. If you're a company, particularly we deal with a lot of companies that want to be part of the defense supply chain. But if you're a company that's been hit with a ransomware attack, you have to wonder how many prime contractors are going to want to work with you. And so that cost really does add up very quickly. And like you said, it's not an if, it's a when. It's not an if you're going to get attacked, it's a when you're going to get attacked. So, but
another point I wanted to raise here is there's nothing like perfect cybersecurity. And I always model a cybersecurity problem as an economics problem. Like if you invest a certain amount of money into your cybersecurity controls, how much does that up the bounty for the attacker, right? So you can always have simpler solutions, or rather like less costly solutions and still provide certain cybersecurity controls. One example is simple training to have strong passwords, whatever that means, right? Like it's probably fairly inexpensive to implement. Now, is that sufficient? That definitely raises the bar for the attacker, but how much, right? So yeah, again, cybersecurity is also an economics problem here. Is the solutions that you invest in, is it sufficient to raise the bar sufficiently high that the attacker would not be motivated to attack you? So that trade-off exists as well.
And that's a really good point to make. That the more secure you make yourself, sometimes you then it really does. It's sort of like the deterrent. It's like having the Ring sticker on your window. If they know that there's a camera watching them, is somebody going to try to break into the house? So sometimes you can, like you said, you can raise that bar. Want to make sure I get to these other questions. Kimberly came back with another question. Is there a link for the free training resources that you were talking about earlier? Where can we find that?
So the chat is inactive, but maybe we can send out an email, Rick, with those links. We're happy to provide those here.
Yep, absolutely. We'll be more than happy to do that. And then we have Teresa asking us, what is the name of the center in San Antonio that offers free cybersecurity resources?
It's the Manufacturing Innovation Institute. It's called CyMani. And it does not offer all of its resources for free. So there are certain resources that they offer for free, but it's CyMani. If you go to cymani.org, I think that's their website. Yeah.
Excellent. Thank you so much.
Another MII that I would point out is MXD. They actually have a virtual training center where a lot of these courses and training material are offered for free as well, which is mxdusa.org. Yeah.
Yep. And we at Project Spectrum are well aware of MXD, and we've viewed their resources in the past, and again, I always want to make sure that I'm putting in a plug for Project Spectrum as well, because anybody who is looking for no-cost cybersecurity resources that are designed for everybody from the novice to the expert, We want to make sure that they understand everything that's available through Project Spectrum. All you have to do is register for the site. There's absolutely no cost to do that. You then get the entire suite of the Project Spectrum tools. We continue to build upon the offerings that we have, the training courses that we have, the different initiatives that we have, the videos, the blogs, the news articles. All of that is constantly in motion, constantly in development. And then just like you said, the information that you're offering through the University of Maryland, we want to make sure that everybody's well aware of that. And then did you want to give another little plug for the directorship that you have it's CREM, right?
Yeah, it's the Center for Research in Emergent Manufacturing. It's funded by the U.S. Army right now, mostly by the U.S. Army. But the vision of that center is to provide training, workforce development resources for free to in the area of digital manufacturing and cybersecurity to the community. And we also do a lot of R&D work as well, and the tools that we develop also, we make them completely open source and available. But one of the big things, that cyber range that I was talking about, is part of that center. We are going to make it open to public in January. And we really, really want like small and medium manufacturers to be able to use that range for exercises like red team, blue team exercises, just an example. And it would be remotely accessible. So it's, though the equipment is physically located here at the university, we have built a pretty exhaustive cloud infrastructure through which we can remotely program the range. It's unique in some sense because you would find in these MIIs, they actually have factory floors, but those are only for demonstration purposes, right? Not necessarily something that you can go in and program, say, the PLCs on the conveyor belt, right? So, but this range would provide you the ability to do that. Yeah.
Excellent. Well, and so anybody else who asked a question, if we did not get to your question today, we're sorry. We tried to give plenty of time at the end. If there is a question that was asked that we did not answer, we will follow up with Nilanjan afterwards and try to get some answers to those additional questions. So we're going to go ahead and be respectful of everybody's time since we're right at the hour, but we started a few minutes late to let folks jump on. Gonna give just an opportunity for final thoughts. So Kareem, I'm going to start with you. Any final words on what we've learned today, or on Project Spectrum, or anything else that's on your mind?
Oh, that's great. That's great, Rick. Listen, I want to first thank Dr. Banerjee. I think an excellent dialogue here. Couldn't be more apropos given the climate that we find ourselves in from a cybersecurity perspective. I think a lot of nuggets and jewels. I think the audience would agree. One of the things I just wanted to foot stomp as we're talking about those resources from Project Spectrum is the fact that we have those live cyber advisors, right? So we have those folks that are at the ready to engage with you as a company coming into our ecosystem on a myriad of resources that avail themselves through Project Spectrum, whether it's self-assessments for CMMC, NIST 800-171, and even beyond, just for cyber hygiene. I think one of the things, Dr. Banerjee, I think drove home here is that a lot of the problems that we see, even in the manufacturing sector, as relates to cybersecurity, are often due to, in many respects, a lack of education and awareness and training. Right? These are things that Project Spectrum are intently and keenly focused on provisioning at absolutely no cost. So I want to foot stomp that as well. These are resources that are at absolutely no cost to you as a small business coming into our environment. And so I want to emphasize the importance of joining us and taking advantage of those resources as well. And thank you again, everyone, for attending.
Appreciate that. And then Dr. Banerjee, one last opportunity. Anything else you want to wrap up with as we close out this issue of cyber circuits?
Thank you so much for inviting me, and it's an amazing audience. I think small and medium manufacturers, like I've worked with them for a couple of years now, at least in the Maryland area, and you are the backbone, right, of our economy in the United States, and you're doing great things, and making sure that your infrastructure is secure is not only important for your company, but I think for the country as a whole. So thank you so much.
And I definitely want to echo that sentiment, because we do recognize that small and medium businesses really are where the innovation in this country lives. And we are so thankful for you bringing those innovations and using them to help make our country better, help make our country more secure. And we certainly want to give you as much support as we possibly can from Project Spectrum to continue to realize that goal of bringing your innovation and your prowess in the industry and really keeping it safe and bringing it forward. So with that, I'm going to say thank you from the entire Project Spectrum team. I want to thank Mark and Scott on the outreach team for doing such a great job at fielding the questions and handling the webinar. I want to thank Richard and Rob on the leadership side of things for their support with everything. Again, want to thank Kareem for stopping by and telling us all about Project Spectrum. Kareem, one of our more accomplished speakers. So if you get a chance to tune into one of his webinars, I definitely highly recommend it. And then want to say, again, a big thank you to Dr. Nilanjan Banerjee. Thank you for everything that you do at the University of Maryland, Baltimore County, and for everything you're doing for small and medium-sized manufacturers. We really do appreciate it. Thank you so much for joining us today. It's been a pleasure having you again. We'll make sure that we get all of the answers and links and everything we need to out to our attendees today, but we do wish you a very great day, and we wish you the best of success on your cybersecurity journey. Have a great day, and thanks.